This is 6.3. Big idea number one is function operations. We're going to take a look at subtraction first, how it can be used. Basically, function operation is taking any two functions and doing some operation with them. Addition, subtraction, multiplication, division. But here we've got an area problem where we need to try to find the area of the shaded region. And so these are little kind of portions of the circle. And we don't have formulas for that, but we do have a formula for a circle. We do have a formula for a square. Obviously, the area of this square, since the side lengths are x, the area of the square would be x squared. Right? So that area is there. But now to find the area of the circle, we got to do a little bit of work. This is a 45, 45, 90 triangle. It's an isosceles triangle. And you could use Pythagorean theorem. You could say x squared plus x squared will equal your hypotenuse squared. But the shortcut ends up being that this whole length here will be x root 2. And that's just one of the special right triangles you remember from geometry. Now, in order to find the area of a circle, we need just the radius, so we need half of that. So it would be the root 2 over 2 times x. So there's our radius. Let's call this c. We can call that c, and that would be pi. Radius is the square root of 2 over 2 x all squared. So you got these two functions. They change as x. X grows, the circle gets bigger, the square inside the circle gets bigger. Then, the area of that shaded region is going to be the area of the entire circle, which we have as c, minus the area of the square. We've labeled that as s. So we're going to take a is equal to pi square root of 2 over 2 x all squared minus x squared. Just to do a little simplifying, this is kind of that's it, that's the operation. As far as simplifying goes, we're going to distribute this square to everything inside of that. So we still have a pi out front. The square root of 2 squared is going to be 2. The 2 squared on the bottom becomes 4, and that's going to become x squared. 2 over 4 is a half. So we have pi over 2x squared minus x squared. You can leave it just like that. You could factor out an x squared one more time. So we have an x squared pi over 2 minus 1. And there's your new function for the area of that shaded region, no matter what the circle looks like. All right. Another big idea is with addition. So function operation with addition. Sally and Jimmy live together and share their income. Sally makes $22 an hour. All right, so let me write that number down. $22 an hour. Jimmy makes $19. Sally works a different amount of hours each week. Okay, so let's say X is going to be Sally hours. Sally works a different amount of hours each week, and Jimmy consistently works 4 more. Okay, so x plus 4 is going to be Jimmy. Okay, we want to then write a function for their weekly income. So we want to write the Sally income plus the Jimmy income. So Sally's making $22 an hour. It's 22x. Jimmy, on the other hand, makes 19. But his hourly amount is x plus 4. So we can distribute 22x plus 19x plus 76. Combine like terms to make 41x plus 76. So their take-home pay would look like this. Multiply and divide is one other method or one other operation that we can use. Here I've got a situation where rectangular sides are growing. Okay, so imagine that those lengths are extending. And so therefore this shape is getting bigger. Rectangular sides are growing independently by the second, x be seconds. One side length can be modeled by the function f, the other by function g. So we've got the two functions here, one of them increasing at this rate, kind of a slope, a linear equation. So it starts at 6, it's going up a half each second, while the other starts at 1 but is increasing at 3 units per second. And so it says to find the area. Area function, well, it's a rectangle, so it's length times width. You'd multiply 1/2 x plus 6 times 3x plus 1. So f of x times g of x. And just in an effort to kind of condense this, I'm not going to multiply it out, though you could do your FOIL, your expand, and get a simplified a of x. The focus, though, for this one is composition. And this is the big idea that we've looked at a little bit before when we were doing exponents. But let's take a look at how this one can play out in an example. You have a coupon for $200 off the price of a personal computer. When you arrive at the store, you find that computers are also on sale for 20% off. X is going to be the original price. So X is the price. So we don't know. Maybe we're going to buy a $100 computer. Maybe we're going to buy a $1,000, $2,000 computer. You know, doesn't matter at this point. X can change. So 25, number 25 says use the function notation to describe your cost. F of x is going to be our cost. Price is original price again, x, by only using the coupon. So basically, you're just taking your original price and you're subtracting $200. Let's take g of x. G of x is going to represent, now in number 26, g of x is going to represent what if we use the 20% discount. Now, one thing to remember, when you take 20% off, you are saving that 20%, certainly, but more importantly, you need to think about what are you actually paying. You're paying 80% of the price still. So you would take 0.80 and you multiply by x. You're paying 80% of the price. Now, composition takes a function and plugs it in. And it still carries out all of the pieces of the function. Order is just kind of the thing that can vary. So number 27 asks us to form the composition of the functions f and g that represent your cost if you use the coupon first, then you take the 20%. So the coupon is f of x. So I want to take x, I want to plug it into f of x. Then I want to take f of x and plug it into g. So essentially what I'm asking you to do is take g, plug in f of x. And so what would that function composition look like? Well, you start with g, okay? It's 0.80 times input. Well, input was x for our above examples, but now you are inputting the entire function f. So here you would plug in x minus 200. Simplify that and you'd get 0.80x minus 160. So that is f happens first, okay, then g. If we want to do this the other way around, if we want to take our price, x, we want to apply the discount first, which is g of x, and then we want to take g and we want to plug it into f, we need to write the function composition this way. As always, the innermost thing to our input, x, happens first. So g happens first in this situation, then f. And so what would this look like? Well, when we write it, we start on the outside. So we start with f. F is the function input minus 200. So you're going to take input, I'm just going to leave a blank, and then you are going to subtract 200. All right, well, what's our input? Our input this time is g of x, and g of x is just that 0.80x. So we got 0.80x. Really not anything to simplify here. It's 0.80x minus 200. So we've got our two functions. Which one is better? The bottom one. No matter what, you're going to get this 80%. Okay, you're going to take that 20% off. What differs, though, is that when you do the gift card first, you're also taking, you're only really getting that you're getting that $200, but it's at the 80% off of that. And so if you apply the discount, then you subtract the $200. Okay, this is discount or sale, then 200. You get that 80% or you get 20% off, then you still subtract 200. While vice versa, you're decreasing the price by 200 and then taking the 20% off, you're not saving as much. Function composition. You can see how you can put them back and forth and plug one into the other. I'm going to strip off a little bit of the words to this one and just practice a couple more, maybe not get through all of these, but practice a couple more just compositions. Let's take a look at what this looks like. So here's f, here's g up above. We're going to evaluate f of g of x. That's how you would say that out loud. So you start with f. F is 6 times the input to the -1. Right? So there's f up there. And I always like to just leave a blank because that's really what input is. We often put x there, but x is really just a place to keep our input warm. You know, it just holds the spot so we know where to put it. You're going to input g, which is this function over on this side, 3x plus 5, into that blank spot. And just to simplify this one step further, you would take this negative, this whole thing has a -1, so it's 6 over 3x plus 5. And if you want to let x equal 3, you can just simply plug in 3 right here. So it would be 6 over 9 plus 5 would be 14. 6 over 14. It's not going to be the same forwards and backwards. So g of f of x, let's take a look at what that would be. You start with your outermost function. So g is where I start. I write g as 3 input plus 5. All right, what's going to be our input? Well, we're inputting the entire function f. So I take my 6x to the -1 and I plug that in. To simplify this one, my x will go to the denominator, so it's 3 times 6 over x, and then there's still a plus 5. 3 times 6 is 18 over x plus 5. So obviously a very different equation there. If we plug in x is 1, we'd have 18 plus 5 is 23. This last one is called an iteration. I'm not going to go into that one right now, but essentially it's the same thing. You plug the function into itself, and you approach it the same way, except for inside the blank, you would put the same function you just had. Let's talk about domain very briefly here. What are the domain of these functions? Remember, there's two general rules with square roots. Your inside needs to be greater than or equal to 0. No negatives in a root. The other thing that you need to think about is when you have a fraction. The denominator cannot equal 0. So those are the two things you have to worry about. So let's look at this first function. When would this denominator, when would 3x plus 5 equal 0? Well, subtract 5, divide by 3. When x equals -5/3, this does not exist. D&E. Okay. With this example here, when would x equal 0? Just looking at the denominators of these, you got 3x plus 5 in the denominator. There's your denominator. Well, obviously when x equals 0. So when x equals 0, this function does not exist. Your homework assignment for these problems.